Okay, I want to talk a bit about power supplies, basic DC supply using a transformer and bridge rectifier. So let's take a look at that. Okay, start with the transformer. You're going to have 120 volts AC coming in here. And should have a switch and a fuse and all that stuff come out. Let's say we got a, I don't know, 45 volt transformer. You send it to a bridge rectifier. All the diodes point in one direction. Take our output here. Usually you put a filter capacitor here. And how this works is fairly simple. When this end, the transformer is positive and that's negative, current goes through the positive bias diode. Can't go that way, that's the negative. Goes this way, that's the positive, can't go that way. That's the negative, so we get positive, negative. When this is positive, of course can't go that way, it's got to go to positive. So this is always going to be positive and that negative. And we put a capacitor in. Now the AC, as you should know, looks like this, right? This end, here we get a pulsating DC. Now the capacitor is going to charge up, so that's going to become something like this, right? The more current you take, that's going to become more like that. This, you know, it's gonna drop down. So the size of the capacitor is going to determine our average level of DC. These diodes are going to conduct more to charge the capacitor during the positive cycle. The capacitor will supply the load when the voltage from the transformers down there, because it's not contributing. So as we load this down, take more current from it, we're going to find our voltage dropping because of this. I can't draw it that well, but you get the idea. Now what would happen if our voltage is too high? Sometimes you can't get the transformer you want. It's always better to buy one with a higher voltage, and I'll show you why. There's a technology, it's been around for years. It's called a buck transformer. It's simply a low voltage. Could be 6, 12, 18, 24 or something like that. Let's go with a 6 because that's what I'm using. We have our main transformer. Now that's going to AC 120. And the primary, of course, we're going to hook there. But we're not going to hook that end to there because that would be dumb. That goes to here. That goes. So this guy's getting 120 volts. But this one is not. We wire this out of phase so that 6 volts bucks the 120 from there, and this voltage is going to be lower. The higher this is, the lower that is. So we won't get 45 there, we might get 40. You'd have to measure it. Things are changing according to load and everything else. Now the reason we don't want too high a voltage, we have a regulator. For a lead, say you want 32 volts here. If you got 50 volts over here, you're losing 18 volts across the regulator. If you're drawing 3 amps, that's almost 60 watts. Right? What are 3 8s? 24, 54 watts. That's a lot of watts to waste. Plus, maybe you'll burn out your regulator. Okay, let's take a look how that works. Right now this is just hooked up normal. If we look at the DC coming in, it's way high, 58 volts. Our output, as you can see, 36, 37, input 50. We're losing a lot of watts in the regulator because of that high voltage. Well, let's set up a standard here. I'm going to draw 2 amps. My output's 39, input 52. So that's 12, 13 volts lost. Okay. I'm going to rewire this primary into the buck transformer. Get our 2 amps. Now you can see it's only 45. We've saved 5 volts. Of course our output is the same, 38, 2 amps. I get it up to 3 amps. Can't quite get for some reason. I've got 42 in, 39 out. That's a 3 volt difference. You really can't get less than that. But my input is down. It's only 42 volts, which is a lot better than 50. And that's how all that works.